let's figure out how to use this z-distribution now that we've got some experience with it. We're going to have to do something called standardizing a variable in order to use this, which basically turns it into a z-score. So remember, for the standard normal z-distribution, the mean is 0 and the standard deviation equals 1. And that tells you where on the curve the value is. So we're going to take our value and we're going to turn it into a z-score. And the way we're going to do that is we're going to take our value x, so this is our value, and we're going to subtract the mean, and then that gives us a deviation. That should be starting to sound familiar. And then we divide it by the standard deviation. So we take the deviation that we calculate and we basically standardize it using the standard deviation. Okay? And that will turn it into a z-score. And that will tell us how many standard deviations above or below the mean our value is. So that translates it onto this curve. For example, suppose we're interested in the value 5 in a distribution that has a mean of 3.5. It has a standard deviation of 1.25. So like one standard deviation above that would be 4.75. And another standard deviation would be 6.0. So our 5 is going to be in here somewhere. Okay, so our z value that we're going to get is going to be positive. It's going to be above the mean because 5 is greater than 3.5. And so here our z is equal to 5 minus 3.5 divided by 1.25, which is 1.2. Okay, so that's our z over here somewhere. So in z terms, and our z here is 1.20. Okay. What if x is 1? Well, now x is less than the mean, right? So our z would be 1 minus 3.5. We're going to get a negative number divided by 1.25. And so that's negative 2.5 over 1.25 equals negative 2. Okay, so that z is going to be a little further out, 2.00. Okay. For r, you don't need all the decimal places, but if you're using the table, you need 2 decimal places, so keep that in mind. Okay, so there's our 1.2 and our negative 2. So now the question is, what is the probability of getting an x of 5 or less, which is the same as the probability of getting a z of 1.2 or less, right? So what is the probability of getting a z equal to 1.2 or less? And more than 5 will be the complement of that. So if we have 1.2, in R, we put p-norm 1.2, and we'll get the answer. In our table, we'll go to the 1.2 line, and the second digit is a 0, so we're going to be right here in the first column. Here we go. And so it is 0.8849. There we go, 0.8849. Okay. So that is the probability of getting an x less than or equal to 5. And the corresponding probability of x greater than or equal to, just say greater than 5, is 1 minus 0.8849, which is equal to 0.1151. And you can do that, again, a couple of ways in R, depending on if you want to use the lower tail equals false, or if you want to take 1 minus your p-norm. For the negative 2, 2.00, okay, again, you'd put in p-norm negative 2.0, and you'd have the probability to the left. That is way down here in the corner. It's 2.0 down here. And again, we're in the first column because it's 2.00. And so it would be 0.0228. So the probability of x being less than or equal to 1 is 0.0228. And this side, probability of x greater than 1, is 1 minus 0.0228 equals 9772. So in general, there's a cycle here. We have a value, x, and we want to standardize it and put it onto our z, which then allows us to either use the table or use the function in R. And from that, we get a probability. So we start with x, we translate it to something where we have a model we can use, and then we get a probability.